Hello, everyone, and welcome to the webinar. So in this webinar, together with my colleague, Dr. Sofia Tsokani, we will introduce network meta-analysis of diagnostic test accuracy studies. And the objectives of this presentation are to introduce diagnostic test accuracy studies, discuss about the process of conducting a systematic review with diagnostic test accuracy meta-analysis very briefly, present how to build the network geometry of DTA studies, and then Sophia will discuss about how we can extend meta-analysis of diagnostic test accuracy studies to network meta-analysis of diagnostic test accuracy studies, so the methods that we found with our scoping review, and then identify some potential implications in DTA and MA. But before we start, we would like to get a sense of who is joining us today, and we would like to run the following poll. Thank you, Dario. So maybe you can take a moment to answer this quick poll. Which of the following best describes your role? Okay, so it seems that 34%, most of you actually are systematic reviewers. We have a lot of statisticians, 31%. We also have methodologists, editors, and users of systematic reviews, and others. So that's wonderful. Hopefully this will help us tailor the discussion today. But we also have a second poll with you before we move on. And similarly, we would like you to answer the poll about your familiarity with DTA meta-analysis. Okay, so it seems that the majority is aware of DTA meta-analysis but hasn't applied that. And also some people know that the 28% know about meta-analysis, diagnostic test accuracy meta-analysis, and have used that. And there are some people who have no idea. So hopefully this webinar will give you a sense of what this is and how we can extend, let's say, those methods to DTA and MA, just give you an introduction around this topic. So I will start by saying that the diagnosis of a medical condition is an important step in healthcare decision-making. So diagnostic tests are used to indicate whether an individual has or does not have the disease. So most tests are imperfect, right? So in discriminating between the patients with or without the disease. And that's why we need to assess the diagnostic accuracy. We need to evaluate their diagnostic accuracy. So to do this, we use the reference standard as the reliable or the optimal test to infer on the presence or absence of the disease. And through this assessment, we get a binary outcome, a positive or a negative test result, such as the COVID-19 test results, for example. We have potentially positive test results for individuals and negative test results for individuals. So the diagnostic performance of index tests is commonly described using two basic concepts. We have sensitivity and specificity. So sensitivity gives us the proportion of those with the disease that the test detects. So it describes the ability of the test to correctly identify the diseased individuals. And specificity gives us the proportion of those without the disease that the test gets right. So it describes the ability of the test to correctly identify the non-diseased. And in order to calculate those values, then we need to, usually we need the 2x2 table to infer on those for the test versus the reference standard. Now, diagnostic tests may be binary markers, X-rays, which directly indicate the presence or absence of the disease. But we often encounter diagnostic test accuracy studies with tests of continuous results, like the blood tests, for example. And then the positive and negative test results are defined based on the threshold for the test positivity. So if the threshold changes, then the results, the sensitivity and specificity also change. And as the threshold is set in different points, there is a trade-off between sensitivity and specificity. Now, in this hypothetical example, we see the distributions of the test results for those without and with the disease on the continuous scale. And moving the threshold from 100% to 110 or 90 and so on, we can see that those green and yellow areas, the false negative rates and the false positive rates, also change. So, for example, moving the threshold from 100 to 110, we can see that sensitivity decreases from 90% to 70%, whereas specificity increases from 90% to 99%. And similarly, if we change the cutoff value from 100 to 90, then we can see that sensitivity will increase and specificity will decrease. So there is a trade-off between sensitivity and specificity as the threshold is set to the different points. And that's what it induces actually correlations. That's the threshold effect. Now, it should be noted that the same threshold can actually give or imply different sensitivities and specificities in different groups of people, different groups of individuals. Now, in a meta-analysis, a solution could be to perform a meta-analysis at each threshold separately or at a subset of clinically similar or clinically equivalent thresholds. So we group, let's say, the studies across a narrow range of thresholds where we consider, for example, the accuracy that is similar. However, restricting to a common threshold may actually reduce data in most of the cases, or maybe the common threshold may not be the threshold that the reader wants to know. So to this end, we need to use more appropriate, more advanced methods than the ones that we use in a meta-analysis of interventions. And that's what we are going to discuss in the next few slides. But let us start with an example of a research question addressed in a study of interest. So here we have that rapid antigen test A for diagnosis of COVID-19 in asymptomatic adults. So that's what we need to address. So in this research study, the index test now is the rapid antigen test A for detecting COVID-19 or SARS-CoV-2 infection, and that's the target condition. And then the population is asymptomatic adults. And finally, the reference standard is the PCR test. So these are the 4 key criteria in this research question. Now, let us consider that in this example, we also have the 2-by-2 table where we have the true positives, false negatives, and true negative results. The total number of participants in this study is 130. And according to the reference standard, we can see that the truly positives are 30 individuals, and the truly negatives are 100 out of the 130 in total participants in this, or individuals in this test, in this study. Now, to describe how well the rapid test performs in those with and without the condition, we can calculate the sensitivity and specificity. So here, the sensitivity is actually the 27 out of the 30, that is the 90%. And the specificity is calculated as the 98 over the 100, that is actually the 98%. So the sensitivity now suggests that the test is positive and identifies the 90% of those with the disease, whereas the specificity suggests that the test is negative and identifies the 98% of those without the disease. So a test with high sensitivity will have few false negatives. So we expect that any negative is probably a true negative. So it is being used to rule out the presence of the disease. Whereas a test with high specificity will have few false positives. So we expect that any positive result will probably be a true positive. And tests with high specificity are usually used for ruling in the disease. Excuse me. So, for example, the COVID-19 rapid tests that we have been using have usually high specificity. That means that a positive result is most probably a true positive result. However, the clinical utility of the test depends on both measures, both sensitivity and specificity. So it is always important to report both measures, both sensitivity and specificity, in pairs and not separately. However, we rarely have only a single study that addresses the question of interest, and a systematic review of all relevant studies may be helpful. Now, the steps of a systematic review with diagnostic test accuracy meta-analysis are similar to the steps used in systematic reviews of interventions. So we start by defining the research question, and this is important as it reflects the review objectives, determines the eligibility criteria, it can guide the search strategy, and so on. Here, for example, in our previous review of diagnostic test accuracy studies, the review question was, what is the diagnostic accuracy of rapid antigen and rapid molecular tests for the diagnosis of SARS-CoV-2 infection in adults and children according to the reference standard, the PCR test? So from this question, we can get all the information that we need. We can get the population, refers to the excuse me, today my voice is really bad. So it refers to the population where we have here adults and children. We have the index tests, and here we have the COVID-19 rapid and rapid antigen test and rapid molecular tests. And then we also have the target condition, that is the SARS-CoV-2 infection. So these three key items can be obtained from the review question. Now, when defining the research question in interventions and DTA reviews, the key elements to be defined are similar, but not the same. So as you can see, and as you know, in the intervention reviews, we have to define the PICO acronym, the PICO criteria: population, interventions, comparators, outcomes, and study design. Whereas in DTA reviews, we have a different acronym, let's say 3 different key criteria to define. So we have the population, we have the index tests, and then we have the target condition. So in the population, we usually term this as population instead of patients, that we have been used to the PICO acronym in the interventions, because here we don't have only patients, we may have also asymptomatic, let's say, individuals. So in the population, we need to define the symptomatic or asymptomatic. We need to define people with whether they had prior testing, whether we need to define specific effect modifiers such as age, sex, and so on. So the characteristics of the population. And then we have the index tests, where we defined the tests. If it can be 1, 2, or more than 2 index tests, whether we have used them combined, in combination, or separately. What is the purpose of using those tests? If it's a replacement, an add-on, or a triage. We need to define the threshold of the tests, and so on. And then we have the target condition. Instead of outcome, here we have the target condition. And then in this aspect, we need also to consider the methods or the reference standard that we define the target condition. And finally, we have the study design, which is the same, of course, as in the PICO criteria. Now, once we define the research question and the PIT criteria, we need also to determine the objectives of the review. So the primary objective usually refers to the accuracy of the index test for the diagnosis of the disease in the relevant population. So here, for example, we have to assess the diagnostic accuracy of the rapid antigen and rapid molecular tests for the diagnosis of SARS-CoV-2 infection in adults and children. And then the secondary objectives can provide more details to the review questions, such as exploring differences in accuracy between different groups, different subgroups, variations of the index test, variability of the in the reference standards that were used across studies, and so on. So here, for example, we used subgroup analysis according to sample type, and whether it was saliva, nasal, swab, and so on. Or we also wanted to see what is the accuracy of the tests in symptomatic and asymptomatic participants. Now, overall, the steps of the systematic review, as we said, they are the same with the systematic reviews of interventions. So I will not go through the full process. This is, I guess, familiar to everyone. However, in this figure, we can briefly see that we start with the protocol development, then we move on to the literature search, the screening process, the data abstraction, the risk of bias appraisal, and then we go to the data analysis and interpretation of the results, along with the credibility assessment, of course, of the results in the end, so that we make some evidence-based informed decisions. Now, before I move on, I would like to highlight that it is of major importance when we conduct a systematic review of DTA studies to be transparent in the reporting. So we need to, in order to reduce research waste, we need to use the PRISMA diagnostic test accuracy, the PRISMA DTA. Now, as a next step, we usually try to improve and update the review when possible, of course, and when it's relevant to our knowledge users. But now, for today, we're going to focus on the data analysis step. So once we complete the systematic review process, the next step is usually to conduct a meta-analysis in order to obtain robust conclusions with respect to the research question of interest. And therefore, we summarize statistically, we combine all the available information from the individual studies that, of course, address the same question and evaluate the same index test in order to obtain a summary estimate on the accuracy of the test. Now, the general meta-analysis process involves calculation of a weighted average to increase precision and power against, of course, the individual studies. We also evaluate heterogeneity and we investigate reasons for the variation. So that's the regular process in intervention reviews. But what is so critical in diagnostic test accuracy meta-analysis? So the answer here is the test threshold. So we should not ignore the different test thresholds in meta-analysis, and accuracy may vary with index test thresholds. And the question here would be, how can we average really the accuracy over the different test thresholds, and how would we interpret those results? So we should also keep in mind that thresholds can be different and can be important in both indexed and the reference tests. So that's the key challenge. So a key challenge in DTA reviews is also that we have two summary statistics for each diagnostic test accuracy study. So we have both sensitivity and specificity, which may have different implications. And they are correlated across studies. So we have also the threshold effect. Another challenge in diagnostic test accuracy meta-analysis is that heterogeneity is the norm in DTA reviews. So, and also that the same threshold can be associated with different sensitivities and specificities across different sets of populations. So the general meta-analysis process obtains a single estimate. But this approach is biased, and it is biased towards studies with high sensitivity or high specificity. And it also ignores the threshold as a source of heterogeneity. So in this case, we would require more advanced methods than a simple weighted average. Overall, excuse me, there are two key and popular models to assess the accuracy of a single index test. So we have the bivariate model that estimates the average sensitivity and specificity point. And then we have the HS-ROC model that estimates the underlying ROC curve based on the different thresholds. Now, both models use data on a single sensitivity and specificity pair from each study for a single index tests. But also both models allow for within and between study variability, that is the heterogeneity. They also account for correlations between the diseased and non-diseased across the studies, and they also allow for random effects, the accuracy and threshold to be fitted as random effects, because we expect that the accuracy will vary with clinical and methodological characteristics. So these models have been extended to assess multiple tests in a single model, and Sophia will give us more details on this. But before describing those models, I would like to go back to the comparison of reviews of interventions and diagnostic tests and highlight some key aspects. So overall, pairwise meta-analysis of interventions compares the efficacy or the safety of two intervention groups for a clinical condition, for a specific outcome. Now, in practice, as you probably know, there may be a variety of available interventions for a given medical condition. And the network meta-analysis is an extension of pairwise meta-analysis that enables this comparison of multiple interventions simultaneously in a single model. Now, network meta-analysis of interventions is a well-established approach. But when it comes to diagnostic accuracy and the extension to test accuracy comparisons, this is a less established approach. And a reasonable question would be, why not using the existing network meta-analysis methods for interventions to the diagnostic test accuracy studies? Now, the answer would be threefold. So we have three key reasons for this. One is that the diagnostic test accuracy studies focus on two quantities. So we have sensitivity and specificity that we need to consider. So models should account for both quantities and their correlation and trade-off due to the threshold effect. Second, the index tests are usually evaluated in the same participants. So unlike interventions, which are considered independent, there are dependencies and correlations that should be taken into account in DTA studies. So you may know that interventions are compared between independent groups. So we have different groups of populations, different group of patients. And there we can calculate, we can obtain the ratio or the absolute measures, the odds ratios, the risk ratios or risk differences to compare the efficacy between the treatments. And then third, the diagnostic test accuracy studies can be of any design, and they can be included in the DTA network meta-analysis of any design. So network meta-analysis of interventions include studies that compare at least two interventions. But this is not always the case in DTA studies. We can have one test, a single test, evaluated against the reference standard. So we may have in DTA NMAs, we may have single test studies or studies evaluating at least two tests. And also in diagnostic test accuracy network meta-analysis, the reference standard is not considered as a different test to be included and evaluated in the network that we build. So the reference standard should be considered as the vehicle to show us the truth. So it's not included in the network of the diagnostic tests. So for example, we may have a paired study evaluating test A versus test B according to the reference standard, and that's considered a direct comparison of tests A and B. So let me explain all these aspects in the next couple of slides. So here we have 4 different interventions, including control, that were assessed in 7 studies, as we can see in the table on the right-hand side. Now, in this table, we can see that the data set includes studies comparing 2 or 3 interventions. Now, in the network, we present all the 3 interventions and the control group, as you can see. So all are compared in at least one 2-arm study. So we have at least one paired intervention study, let's say. Now let's take a look at the network meta-analysis of diagnostic test accuracy studies. Suppose again that we have 7 studies evaluating 4 index tests. We have A, B, C, and D in a single test. They are also evaluated in a single test, but also in a paired test or in a triple test design. So for example, in study 1, we have a single test study evaluating test D against the reference standard. And if we go now to depict this study in the network, this is represented in a circle in test D. Now, the second study is a paired test study and evaluates tests B and C according to the reference standard. So this study in the network is represented by a dashed line connecting tests B and C. And then the third study, we can see that it is a triple test study and evaluates tests A, B, and C according to the reference standard. So this study in the network is represented by a solid line connecting tests A, B, and C. And as you can see, studies of any design can be used in the diagnostic test accuracy network meta-analysis. So even single test studies, which is in contrast to what we do and what we include in networks of interventions, they can be included in this network. Now, importantly, in the diagnostic test accuracy network, you can see that the reference standard is not considered as a different test to be included and evaluated in the network. So as we said, the reference standard is the bridge, is the vehicle to tell us the truth about the disease. And that's why we do not consider this in the network. It's not a comparable test, let's say, to the remaining tests that should be evaluated. So I will stop here and we'll hand it over to Sophia to describe the scoping review that we conducted to identify and evaluate all methods to assess the diagnostic test accuracies in a network meta-analysis. And this was a study that was funded, that we obtained funding from the European Social Funds. It was published in the JC.